Hello, welcome to Chapter 5 for Business Math, Savings Accounts. This is Lesson 5.8. It's called Annuities. So we've been going through quite a few different calculations for interest over the last couple of sections. If you haven't had a chance to watch those videos or go through those lessons, I highly suggest you go back because it kind of introduces you to some of the things we're going to do in this table here. Make sure you're looking through your chapter, read the lessons, look at the examples. What formulas are they using? How are they using it? We definitely need to be paying attention to the wording at this point. We should understand, what daily, monthly, semi-annually, biweekly, all of these things should be familiar to us at this point. And then for the last couple, compounded, the word compounded, that was definitely important to understand what compounded meant. Otherwise, the whole problem probably didn't make a lot of sense if we didn't know what that word meant. So pay attention to the concepts, the vocabulary, and especially the examples. All right. So let's go ahead and read the summary here at the top. So an annuity is a sum of money deposited in equal amounts into an account at equal periods of time. An ordinary annuity occurs when equal deposits are made at the end of each interest period. The future value is the amount of money in the annuity account at the end of a specific period of time. To find the future value of an ordinary annuity, find the value of $1 from the table and multiply by the amount of the regular deposit. To use the table, we need to know the rate per period and the table total number of periods. Messed up a few times there. Fun reading out loud to the camera. All right, so future value equals the amount of the deposit times the future value of $1. So what that means is literally they're telling you this is what your dollar is going to be worth in the future. That's quite literally what that means. And we're multiplying the deposit by that amount. So we can see this is what all of my dollars will be worth in the future. And total interest is just the future value that you calculate first minus all of the deposits you've made. So remember, an annuity, just like the summary said, it's a certain amount of money deposited in equal sums over an equal number of periods. So it's not all one lump sum put in right now. It's maybe 1,000 and then 1,000 and then 1,000. So it's over time we're depositing a certain amount of money each time. So we have our table here. And again, these tables, there's usually the expanded tables in the back of the book in the appendix. You can find it, make sure that it matches the title here. So you want to find exactly this title. And then the table will be much bigger. It'll expand it. So you'll have more columns to look at. You'll have more pay periods to look at, or more number of periods, to look at, kind of a thing. So this is just a very small piece of the table. Just in case you didn't know, that was in the back of the book. It's definitely there. It's in the appendix. It's got like a little blue tag on it that says appendix, and then it starts in it. The page numbers are like A1, A2, A3. This one should be around, I want to say like A10, A9. I believe that's where it is. All right. So Rodolfo Balderas deposits $400 in an ordinary annuity at the end of each quarter in an account earning 6% interest compounded quarterly. What is the future value of the account in 2 years? How much interest is earned? So we have two questions. First, what's the future value of the account in 2 years? And then we have to calculate how much interest he's earned. So we just have to take a look at a few of the important pieces here. So first we have $400. So first we have $400 that he's depositing at the end of each quarter, and he's earning 6% quarterly on that. So we just have to pay attention to the quarterly as well, because that's going to tell us where to look in the chart. So we did this one, I believe it was section 5.6, if I remember correctly, where we had to kind of divide this down. So this word here tells you what to do with the 6%. So I'm going to take 6% and I'm going to divide by quarterly. Quarterly means 4 times a year. And this will tell me the percentage that I'm going to look for in that table. So I'm going to look for 1.5% in the table along the top here. So I have 0.5%, 1%, 1.5%, and 2%. So I don't have a whole lot going along on the top, but we should always end up with one of these four, at least for the first few. Sometimes when we get down to the bottom one, they give us kind of a wild one that's a little different. All right. So now that we have our 1.5%, we need to pay attention to how many times it's actually going to be compounded over 2 years. Remember, this is 4 times a year. So this is 4 times for 1 year. So if it's 4 times for 1 year and I have 2 years, that means 8 times total. So I'm going to go down to 8, and I'm going to go over to 1.5, and here it is. So 1.5 if I go straight down, 8 if I come straight over, and that's where they meet. So it's kind of like a multiplication table, right? And we've done this a couple of times. I know we did it in 5.6. I believe they had it in 5.7. I think we had another table in 5.7. Yeah, we did. The 5.7 table wasn't quite two-way. It was just kind of the days along the side, and you just go straight over. So two-way table, just you have to go down and across and kind of where do they meet. All right, so this is the amount that we're going to multiply his deposits by. So we get 400 times, and it's 8.43284. Did I write that? 43284. Yeah. So, and if you're paying attention too, it's 8 times, and if you notice there's an 8 in front of there. So that's important. If you look at the table here, everything along the 8 column has an 8 in front of it. Everything in the 7, sorry, not column, row going across here, has a 7. 6 row has 6s, 5 row has 5s. Hopefully we can see that pattern. That's definitely important to recognize, because that means the number of times we compounded, basically, or number of times we not compounded in this one, it's deposited. All right, so once you calculate this amount, that's going to be your answer for part A. That tells you how much the future value of this money is in 2 years. The total interest is going to be this amount, and I'm just putting a box here. Remember, that's the amount for A, and I'm not calculating for you. It's a pretty simple calculation there. So we're going to take this amount, and we're going to subtract everything we deposited. We deposited 408 times. So don't forget, it's 408 times, 400 times 8. And then we're going to subtract that from this amount here. That'll tell us how much interest we earned over that 2-year period. All right, so we're going to take a look at the next page here. I believe, yeah, this is the last section in this chapter. All right, so same idea on this next one. She deposits $1,000 in an ordinary annuity at the end of each quarter, in an account earning 4% interest compounded quarterly. So remember, quarterly means 4 times per year. So we want to take that into account right away, because number one, that tells us what to do with this 4%. We have 4% divided by 4. So that means 1% for each quarter. And then the first question is 1.5 years. So if it's 4 times in a year, well, the second year, I'm not going to have a full 4. I'm only going to have 2 of them, because it's half that year. So it's going to be 6 times. So now we know we're going to use 1% along the top of the chart. We're going to use 6 times along the side, and we're just going to, whoop, what number do I land on there? And that's what we're going to multiply the $1,000 by. And it should start with a 6, right? The number that we land on should definitely start with a 6, because it's 6 times. All right. And then to get the total interest, remember, you subtract the amount that you get right here from 1,000 times 6. You deposited 1,000 6 times. Okay. And that'll tell you how much interest we earned again. All right, let's see. Same idea in this one. The only difference I'm going to point out is compounded monthly. So remember, that means 12 times. So we're going to take our 6%. We're going to divide by 12. That'll give us our percent that we look for at the top of the table. And then 6 months. So simple enough. It's just 6 months there, we don't necessarily need to do anything because it's each month, just 6 of them. So 6 along the side. We're going to look for this percentage along the top. I'm going to let you calculate that along the top. It should start with a 6, the number you land on, because we're in the 6th row there, right? So it should be 6 point something. That should be definitely what we land on. And then you're just going to multiply that number again by the $100. And do the same exact idea for part B that we've done in the last ones. You subtract the amount you get here. That's what's in her account, or the future value of her account in 6 months. You subtract that from 100 times 6. Remember, she put $100 in every month for 6 months. So we don't want to just subtract from 100. We want to subtract every deposit she put in. All right, an annuity due occurs when equal deposits are made at the beginning of each interest period. In an annuity due, the money starts earning interest immediately since it is deposited at the beginning of the first period. Sorry, at the beginning of the interest period. So future value of an annuity due equals the future value of an ordinary annuity times 1 plus the rate per period. So it's a little different calculation on this one. So now they're changing it up a little bit. It's not just an ordinary annuity, it's annuity due means that it's immediately earning interest right now. So let's go ahead and take a look at this one real quick. So we have Lee Troiler deposits $400 in an individual retirement account in the form of an annuity due at the beginning of each quarter. The account earns 8% interest compounded quarterly. What is the future value of the account in 2 years, and how much interest is earned? So the main thing we want to do is go through and again identify we have quarterly. So I'm hoping by now we've done that a few times. We know that it's 4 times for the year. So we're going to take our 8%. We're still going to divide by 4 so that we know what to look for in that table. Okay, so and I'm going to go ahead and do this calculation. It is, I'm going to make sure I have that kind of funky written. I think it's 2.5 is what that ends up being. Mm, 8% divided by 4? Nope, I couldn't read it very nicely there. 0.02, which is 2%, okay? Not 2.5%. All right. So we have 2%. That's what we're going to look for at the top of the column there. And then 2 years quarterly, so very similar to when we were doing on the previous page there. It's 4 per year. I'm going for 2 years, so 8 times. 8 times. All right. So the main difference here, and I'm going to go over here and I'm going to grab my number. Boop. Scooch down just a little bit. So it was 2%. So my last column here, and I'm going to go all the way down to 8. So here's my number that I want. So I'm going to have 8.58297, and I put in my calculator just so I can remember it from page to page here. And we're going to multiply that by 400, because remember that's the future value of the annuity. So 8.58297. Sorry, that came out a little sloppy. And that gives me this piece here, the future value of an ordinary annuity. That's what we've been doing this whole time. So we're going to calculate that amount, and that's going to be multiplied by 1 plus the rate per period. So that's where we kind of get a little bit different here. So the rate per period, that's this one. We already did that. And 1 plus that rate per period, remember we're doing the decimal version, not the 2%. We have to change it to a decimal. So if we're just adding 1 to this guy, well, 1 would just go right in front there, right? So we have 1.02. So we want to take this answer and multiply by 1.02, like that. And that will give us, I'm going to put equal here, that will give us our end answer. So our actual value of the annuity due. And then we do the same thing for the interest earned. We want to subtract this amount from all the deposits we put in. If it's $400, 8 times, we multiply that and subtract from the answer we got from part A here. All right. Number 5 is the algebra one. This one is a little bit more involved. That's kind of my way of saying it's definitely got a few more steps here. So the Fosters vowed on their wedding day to have saved $1 million by their 50th anniversary. The future value formula to determine how much the Fosters would have to save monthly at 6.6 interest compounded monthly in an ordinary annuity to save $1 million in 50 years. All right, so first we need to know the rate per period, like this right here. So we're going to take our 6.6% and we're going to divide by 12 because they're doing it monthly. Where do they say that? Monthly, save monthly, right? So we have a 0.0055. That's our rate per period. Every month, that is our rate. So now the number of periods that we're doing this over, it's, and I'm going to go N for the number of periods, is 50 times 12 because it's 50 years, 12 months every year. So we're going to do 600 months. That's how long they're saving for 600 months. My goodness. I'm going to scooch this down so I have a little bit more room here. All right. So now I can start to put this into the future value formula. So the future value formula is annuity due, and I'm going to write this out. It's going to look a little complicated. $1 plus, and sorry, this is a bracket, plus the rate N minus $1. Something like this. And that's all divided by R. Okay, so now let's go ahead and start putting this in. So we already have our R and we already have our N. So this is the formula that we're going to use to calculate this using the future value formula. So this is kind of the more complex looking formula we have here. So our future value, we want $1 million. That's what they want to have. And we don't know what they need to put in. That's what we're trying to figure out. What do they need to save each month in order to accomplish this amount? So when we put this piece in, we're just going to plug in what did we get for R here? We got plus 0.0055. And then N, we already calculated N, it was 600. So there was a reason we calculated those to begin with. And then we're going to subtract 1 from that before multiplying. And this is all over the rate again, all over R, which is 0.5. Okay, let's simplify this a little bit before I let you guys do the rest of the calculation here. So we have a million. We haven't done anything with a million. It's still a million on the side. AD. And then let's simplify this piece. We can add these two pieces together. So we're going to end up with 1.0055 to the 600 minus 1. Boom, like that. That's all over Sky. Okay, so all I did was add these two pieces together. So now I'm going to bring my calculator over here so you can kind of see it. So like I said, $1 plus 0.0055. That got me this amount here that I have in the parentheses now. I forgot my beginning part of the parentheses there. All right, bring my calculator back to the front. All right, so now I'm going to raise it to 600. So remember, we click on this symbol here because I can tell it I want the y, I want my exponent to be 600. And then I click equals. There's my number, and I'm going to scooch this over to my other screen so I can see it. So I have 1 million equals AD. Sorry, I'm going to be writing right over the top of this. I didn't plan that out very well. So remember, this number is now taking the place of the parentheses. That was that calculation. So I'm going to go ahead and say minus 1 so that I just have one number on top. So my number on top is going to be 25.86. Sorry, this was 0.868595. Try not to round too early. I've talked about this in previous videos. Rounding too early will kind of mess up your calculation. Okay, So now we can actually start looking at solving this equation. So let's see. What they want you to do in the next step, and I'm going to kind of let you guys finish this off. I know it's getting long numbers. I definitely suggest you type this back into your calculator. Don't just type in this amount. You'll get the wrong number. This is very rounded. The full number is much longer. I stopped here, but it keeps going. So you're going to multiply a million by this 0.0055 to move it out from under the fraction there, because we're dividing by it on this side, on the left or the right side. So to move it, I'm going to multiply on both sides to move it over here to the left. And then once I have AD times this 25 point long number, instead of reading that whole thing, then it's times here. I can just divide by this number, the answer I got on the side. If I divide by this number, I'll figure out what the AD has to be. So it'll tell me how much the Fosters need to save every month in order to make this happen. All right, so I'm going to let you guys finish that off. I know I didn't do the whole calculation there. I only did about, well, a little bit more than half of it, but it's definitely set up for you, so you can keep moving forward on this one. And I hope that helped. I will see you in chapter 6.